Hi, hello, welcome to Homeschool. This is your class 11 mathematics, NCERT or CBSE board. We are in our first chapter sets and today I am going to discuss with you exercise 1.3. Before starting exercise, we are going to discuss some types of sets. That is, what is a subset? Power set, what is a universal set, what is a proper subset and improper subset, what is a superset, singleton set. After this, we are going to continue the exercise, right? Let me take a set. We take a set with a letter B. B is equal to 1, 2, 3. These are the elements and the set is represented by a capital letter. There are 3 elements inside the set. Okay. And another set I am going to take here. A is equal to 1, 2. First compare these two sets. What you can say? 1, 2. In B set also you can see 1, 2. Right? I say that A is a subset of B. Subset meaning all the elements contained in this set are also contained in B set. Observe the two sets carefully. 1, 2. 1, 2, 3. See here in this set other than 3 you have 1, 2. That means all the elements in A are present in B. All the elements in A are also contained in B set. So this is called as a subset. A is a subset of B, I can say. Only one subset you can write from the given set? No, you can write some more subsets. Later we are going to learn that. First we are going to know the definition of a subset. Subset. A set A is said to be a subset of A set B if every element of A is also an element of B. Let's see the definition again. A set A is said to be a subset of a set B if every element of A is also an element of B. Yes, can you understand? 1 and 2 is the element of A. These two elements are also the elements of set B. Therefore, I say this is a subset. A is a subset of B. How can you denote this? Subset can be denoted by using a symbol. Denoted by symbol like this. Okay, this indicates subset. And now, by taking this example, how we are going to write? A set is a subset of B set. Write like this. A subset of B. A subset of B. Or you can take any elements and you can say, how you can say this one? If 1 belongs to A implies 1 belongs to B. And you can write this as 2 belongs to A implies 2 belongs to B. How you can read this? If A is a subset of B, if 1 belongs to A, 1 belongs to A means 1 is an element of A set, right? Implies 1 is also an element of B set, right? If you want, you can write with another element also. 2 belongs to A implies 2 belongs to B. Okay, 2 is an element of a set A and it is also an element of set B. Okay, like this you can say any subset. Normally you say A is subset of B if A belongs to A implies A belongs to B, where A is an element of A and A is also an element of B. A subset of B. Right? Is this clear? Now let me take one more set. Suppose let me take C is equal to 5, 6. And what does B you have taken? B is equal to 1, 2, 3. Now check these two carefully. 5, 6. This C set, is it a subset of B? No, I'll say. Why? All the elements which are present in C set should be contained in B set. Do you have B set same numbers? No, elements are different. The elements are not contained in B set. Therefore, what I can say? C is not a subset of B. This is used to represent not a subset. And this symbol is used to represent is a subset. Right? This is subset and this is not a subset. Now let's see, by taking this set, how many subsets you can write. Okay, let me write this again. B is equal to 1, 2, 3. Okay, start writing all the subsets. By taking every element, you can form another subset. And 2 elements, 3 elements, no element also you can form a subset. First, I am writing empty set. Empty set is always a subset of every set. Empty set is a subset of every set. You can write or you can remember in this manner. Empty set is a subset of every set. Is a subset of every set. So first subset I have written empty set. Right? Next, I can take only one number and make a set. I can take only one and I can write it as a subset. Next number 2, next number 3, next I take pairs 1, 2, 2, 3, 3, 1. Finished? No, every set is a subset of itself. Write one more subset with all the elements contained in the set. See here, empty set, set containing only 1, 2, 3, 1, 2, 2, 3, 3, 1, 1, 2, 3. So how many number of subsets you can write from this set? The set has 3 elements. So let us start counting. 1, 2, 3, 4, 5, 6, 7, 8. 8 subsets I can write by taking a set. Okay, containing 3 elements. Now among these subset, empty set is a subset of every set. And observe this one. Every set is a subset of itself. Remember these all points. Every set is a subset of itself. Okay. Now, one more word I forgot to say for you. Suppose if A is a subset of B, A is a subset of B, then what is B? B set we call it as a superset. Okay. If A is a subset of B, then from which set this is subset? That set is called as a superset. Okay. And next coming to proper subset and improper subset. Look here. Empty set and the set which is a subset of itself. Same set where you have This is improper subset. Why improper also I'll say. This is also improper subset. Then the remaining subsets all what you form? Those are all called as the proper subsets. Proper subsets. Why they are proper and why they are improper? See here, empty set. There are no elements. There are no elements. That is an improper subset. And all the elements, same element set, I won't say it as a proper subset. So, same set when you write in subset, that one and empty set will be improper. Remaining all subsets will be proper subsets. Okay, is this clear? Or shall we take one more example? Okay, let us see here one more example. Let me take a P set. I'll take 1, 2. Only 2 elements in this set. So write all the subsets. What you can write? See all the subsets means first you will write empty set. Next 1. Next 2. Next 1, 2. See here, that's all, no? Can you write any other subset? No. Empty set. With 1 I have made one subset. With 2, with 1, 2. Right? So, among these subsets, which are proper and which are improper subsets? Look here. Empty set and the same subset. These 2 subsets are improper and remaining subsets are proper subsets. Okay, you got a clarity now? Now, one more point I'd like to say. See here, B and this is subset. Suppose if I take this as any P is equal to 1, 2, 3. Observe carefully. P set and B set. Observe carefully. B is a subset of P. Yes or no? B is a subset of P and P is also a subset of B. B subset of P and P subset of B. Then what I can say? This 2 sides arrow mark implication, what does it says? If both sides are equal, therefore I can say B is equal to P. Both the sets are equal. Here you consider A is a subset of B. But both the sets are not equal. Why? They have only 2 elements. There you have 3 elements. A is not equal to B, you can say. A is subset of B and A is not equal to B. Whereas here both a set and a subset both are having same elements and the same number of elements. So what I can say? B is a subset of P. P is also a subset of B. Therefore B is equal to P. Okay, is this clear? So let us see once again. What is a subset? A set A is said to be a subset of set B if every element of A is also an element of B. Subset is denoted by the symbol. Okay, I have taken an example. A is equal to 1, 2, B is equal to 1, 2, 3. A is subset of B. And I have explained you by taking the elements here. 1 belongs to A, 1 belongs to B. 2 belongs to A, 2 belongs to B. Right? With implies I have written here. Okay. Suppose if all the elements of one set is equal to all the elements of another set, I say that P is equal to P or P is equal to B. Okay. Next, not a subset. I have taken example here B and C. See here 5, 6 are the elements which are not contained in B set. Therefore, C is not a subset of B. Okay, not a subset, we need to write like this. And 2 more points you need to remember. Empty set is a subset of every set. Okay, and every set is a subset of itself. Next, how to write subsets. I have taken here 2 examples and I showed you. Just let us see once again. B is equal to 1, 2, 3. Write all the subsets by taking this set. I have written empty set 1, 2, 3, 1, 2, 2, 3, 3, 1, 1, 2, 3. Among these, empty set and the same subset of having same elements in a set called as the improper. These two subsets are called as the improper subsets. Remaining are called as the proper subsets. And one more example here, P is equal to 1, 2. From this set, write all the subsets, empty set 1, 2, 1, 2. Among these, this subset and that subset are called as the improper subsets and remaining two are called as the proper subsets. And the next one, superset. What is superset? Suppose if I say any set is a subset of this set, if I say, okay, look here. This example, let me take, right? If A set is a subset of this set, I am saying, that means 1, 2, only 1, 2 are present in B set. That means A is a subset of B and A is not equal to B. Why not equal to? It has another element which is not there in A set. If that element also there, I say that A is equal to B. If A is subset of B and A is not equal to B, then that B set we call it as a superset, right? Now, in this also you compare. See here, this and this you compare. This is a subset, then this is a superset. This is a subset, then this is a superset. And here, these two are same, so I cannot say superset. When I compare these, I can say this is a superset. Then if I compare this subset and this set, both are same, then I cannot say that as a superset. Okay, superset, how will you represent? See here, subset we have seen now, same opposite direction is used to represent superset. So look here carefully, A is a subset of B and A is not equal to B. Then B is a superset of A. Okay, A subset of B, A is not equal to B, then B is superset of A. Next, let us see the number of subsets. How many number of subsets you can write from a single set? Suppose if I take A is equal to 7, 8. A is equal to 7, 8. How many subsets you can write? Write here, empty set 7, 8, 7, 8. I can write n of A is equal to 2. Then number of subsets. Number of subsets is equal to 2 power n of A. 2 power n of A. So n of A is how much? 2 we got. Let us substitute 2 power 2, that is 4 is your answer. Now count the subsets. 1, 2, 3, 4. Yes. So same manner. Let us see one more example. B is equal to P, Q, R. Okay. Write all the subsets. First subset is empty set. Next with the P element. Next with the Q element. R, P, Q, 2, 2. Next. QR, RP. And the last one is same set PQR. So now count how many subsets you got. 1, 2, 3, 4, 5, 6, 7, 8 subsets. Okay. Now number of elements in B set. How do you write? N of B, cardinal number we call this one. Cardinal number of a set. N of B is equal to 3. If N of B is equal to 3, then Number of subsets. Always we remember 2 power n of b. Here letter what you have, that letter you can take. I have taken set b letter. So n of b you write. 2 power. How many elements are there in the set? 3 elements. 2 power 3 means multiply 2 3 times. 2 2s are 4, 4 2s are 8. Check it out. 1, 2, 3, 4, 5, 6, 7, 8. Yes. How many number of subsets are there? 8 number of subsets you can write from a set of containing 3 elements. Same manner, suppose if you have 4 elements, how many subsets? Just simple, very simple. 2 power n of c, that is 2 power 4. 2 power 4 multiply 2 multiply 4 times. 2 2s are 4, 4 2s are 8, 8 2s are 16. How many subsets? 16 subsets you can write from a set containing 4 elements. Okay. If you know number of elements in a set, you can write how many subsets you can frame using that set. Okay, very simple. That is 2 power n of that set you take. Will give you the number of subsets. Next, let us deal with the power set. What is a power set? Do it have more power? Yes. Power set is represented by the letter P. By the letter P. Suppose if I take this example, right? You have written all the subsets, right? This one I can write P of A is equal to, again with a set and in between comma, this is a power set. Power set contains all the subsets of a set. The collection of all the subsets of a set A is called as a power set of A. It is represented by the letter P, power set of A. See here, what is the difference? All subsets I have written with the commas and enclosed with the flower bracket. This is a power set. How many elements are there means? If you know number of subsets, that is the number of elements contained in power set. Okay. So this one also same manner. The collection of all the subsets of a set B is called as a power set of B, and I write with a flower bracket, commas for every subset, okay, enclosed with a flower bracket. So this one, power set of B, it contains all the subsets of B. Collection of all the subsets. Same manner. How many elements are there in a power set means? Same formula. Number of subsets or how many elements in power set? You can use the same rule. Okay, is this clear? Next, coming to universal set. What is universal set? Universal set. Universal set is represented by capital U. What is universal set? Some problems we are going to deal with subsets and some elements. So combinedly all sets are contained in the universal set. What is a universal set? A set containing all the given sets is called as a universal set. What is universal set? A set containing all the sets are called as universal set, and it is denoted by the letter capital U. Okay, universal set contains all the sets. Next, one more set we are going to learn, that is singleton set. What is singleton set? Singleton set, having only one element in the set. Having only one element in a set is called as a singleton set. right? And two more points I'd like to discuss here. Suppose in power set, if only empty set there, suppose in power set, if you have only empty set, or you can write like this. So how many elements are there? Normally, if empty set is given, you say that there are no elements, right? But in power set, these all becomes in power set, all these subsets become the elements, right? Empty set, we need to consider it as a one element. Okay, so you may write this one like this. Power set containing one element. Don't say that empty, there is no element. Here it is no element. Suppose you have only like this, there are no elements. And here one element is present in the power set. Okay. And one more point I'd like to discuss where most of you are confusing in exam. That is subset and belongs to. Look here, let us take any one example. Subset if I talk, A is equal to 1, 2, 3, 4 I am taking here. Okay. Suppose if I say only element 1 belongs to A, you should say. One subset of A you should not say. Right? Subset. When you enclose this number with a bracket, then you should not say belongs to. At the time you should say subset of A. Okay, one more time I say, if you are taking only elements, you need to write belongs to or does not belongs to. So one more example, 3 belongs to A, 5 does not belongs to A. Can you see 5 in this set? No. So 5 does not belongs to A. 3 belongs to A. Then coming to subset. At the time when you are talking about any subset, you should write like this. 1, 2 is a subset of A set. With brackets, you need to say the subset. Or directly set you can say. B is a subset of A, you can say. 2 sets if you are taking. Suppose for the given set, if you give any set letter, then with that set also you can write subset. Okay. With only elements, you should not say subset. Okay, is this clear? See, only when you write subsets, you use this symbol. Only elements if you take, you use belongs to or does not belongs to. Is this clear? Next, we are going to discuss about notation intervals. We come across 4 types of brackets. Right? What are those? 1, 2, and this one. Right? To write any interval, we come across these 4 types of brackets. I think you all know that. This is a round, square, and here round one side, square one side, and here square one side, round one side, you can see. But whereas in sets, we call it as a open brackets. Open interval or open brackets, you can say. And square indicates closed. Okay, easy to remember. Open brackets, closed brackets. Then what about this one? Open, closed. And this one, closed, open. Why? See here, one side it is open. Round means open, no? Square means closed. Open, closed, closed, open. Or you can write it as semi-open closed intervals. Semi-open intervals you can say, semi-open closed intervals you can say. Right? Now, how to understand this? First concept is, when you see this brackets, understand here open. This one closed. So open interval, closed interval, semi-open closed intervals. Right? Now suppose let me talk about the two real numbers. A comma B. A comma B. A comma B. A comma B. Suppose on a number line, open. See here, open down I am giving here A, B. If AB belongs to real numbers. So each interval we are going to understand using a number line. Right? See here, this round indicates it is open. It is open. Okay. So what are these A, B letters? They are having some values. Some numbers are there. Suppose let me say A comma B belongs to real numbers, where A is less than B. That means B is greater than A, right? A is less than B means B is greater than A. Now, see, this round indicates A, B are open. So, from A to B, what you need to understand on a number line? See here, from A, from this point to this point, you need to take. That means A and B are excluded. Other than AB, inside all numbers, we need to consider in a set. Right? So, what I can say, if you have this type of brackets, you can say excluding AB. Excluding AB. Okay, other than A and B. A next number and B before number you need to take. Suppose if I talk about real numbers, if I take any 5, suppose A value was 5. So, other than 5 means what happens? 5.00000001, so on 1, 2, if I take here 7, 6.99999, where it ends we don't know. But what you need to understand, other than 5 and other than 7, 5 and 7 are excluded. Coming to letters, A and B are excluded. How can we write same interval in set builder form? Look here, A comma B is equal to X such that I am talking about X. What is X? It is greater than A and less than B. Don't be confused with the same less than, don't be confused. I am talking about here X. X is greater than A and less than B. Okay. So coming to next bracket, square bracket. That means closed interval. How do you represent on a number line? Look here. End. See. Including this A and including B, all the numbers we can take in the set. Right? So I say this bracket as including. Okay. If you have open brackets, you need to remember excluding the numbers. If you have a closed bracket, you need to remember including the numbers. Right? How you can write this in set builder form? X such that X belongs to real numbers. These are also you can extend there. Right? A, X, B. This is important. You have taken less than symbol. But here A is included, B is also included. Included. Less than or equal to, less than or equal to. Now how to read this one? X is greater than or equal to A. Means A is also there. And then X less than or equal to B. B is also included in the set. A and B is included. With one more example also I'll say for you. Right? Next. See the next one. Open, closed. Open, closed. How we are going to write? Small circle, open. This is closed. Yes, are you able to identify what I am putting here dots? Right? Open, closed. Open means this is not included. B, this is included. Right? A is excluded. B is included. So write this one. A, B. See the brackets carefully. This interval. Curve, square. Open, close you need to say. Set builder form X is such that A less than X less than or equal to B. See here what is the difference? A is excluded. A won't be there. So X is greater than A. But A won't be there. But here X is less than or equal to B. Due to this interval we have written there equal to. Okay. Same manner last bracket. Closed, open. This side closed and this side open. That means on a number line, closed. See, close the dot A. Open, open round B. Okay. This is a part you need to consider. See here carefully. This part we are talking. Suppose it might be any numbers. Right? Square bracket A comma B, closed bracket, open bracket, closed bracket. How do you write in set builder form? Flower bracket, right? X such that. What is X set? X, see here A, B I have written. Now you need to think. It is closed. Closed means and this is included, greater than or equal to, and here less than B. Less than B, B is not included. Greater than or equal to A means A is also included. Don't be confused with what I am saying greater and I am writing here less than. So always we talk with X here. X is what? I am saying X is greater than or equal to A and less than B. Okay, now we are going to understand this by taking a small example with numbers. Right? 5, 7. Okay, here what happens when I write this? 5. Okay, so 5, 7 interval. Open interval. How we are going to write? X such that X is greater than 5, less than 7. 5 and 7 won't be there in it. Right? Next one. Same 5, 7. I have taken A value 5, B value as 7. And now if I take this bracket 5, 7 closed interval. What you can say? 5. See here. X is such that X is greater than or equal to 5, less than or equal to 7. 5 and 7 both are there in the set. Okay. Next here AB. Again I take here with 5, 7. Open, closed. 5. See here. X is and 5. 5 is not considered and 7 is included. Less than or equal to 7. And here, suppose if I take 5, 7, 5, 7, closed interval and this side open interval. So what you can say? 5 less than or equal to X less than 7. 5 is included, 7 is excluded. X is greater than or equal to 5, less than 7. Like this, if any interval given, you could be able to write in set builder form, or if set builder form given, you should be able to write intervals. Okay, so one thing you need to understand is when you have a round brackets, open, you remember. If you have a square bracket, closed. If open, these numbers are excluded. If closed, these numbers are included. See here, open, closed, not included, this is included. And here, closed, open, closed, A is included, B is excluded. Okay, let us take one more example here. Suppose if I take like this. So, say me, 2 won't be there, right? 2.00001 to 5. Right? What are all the elements you need to write here? 2 won't be there, but 5 will be there. Excluded, and here it is included. Okay, so many, if I talk about real numbers, there are many real numbers between 2 and 5. But whereas this bracket indicates 2 won't be there. So 2.00001 to 5 you need to say. I think this is clear about the notation intervals, right? While we are writing in set builder form, we are going to write in this manner, where we are using less than or equal to, greater than or equal to means. This is the way we need to understand. So once again look here, 5 and 7 won't be there. Remaining all inside numbers will be there. And here 5 and 7 will be there. Middle all numbers will be there. And here 5 won't be there. Next 5.0001 to 7 will be there. Okay. Here 5 will be there. 7 won't be there. 6.99999 is the end point there. And one more point you need to remember. So if you need this length if you need, B minus A is the length of the interval. Okay, I have taken that A and B are real numbers where A is lesser than B. Therefore, if you need this length, you need to subtract from B A. Therefore, length of the interval is B minus A. Suppose same condition, if A is greater than B given means, what you need to do? A minus B is the length of the interval. Okay, understanding notation intervals is very important. So if you are perfect with all this, we are going to continue the exercise. Let's start here exercise 1.3. First, make the correct statement and fill up the blanks given with subset or not a subset. See the first one, 2, 3, 4 set, 1, 2, 3, 4, 5 set. They did not give any letters. They have given only set. Right? Now see the elements 2, 3, 4 are also contained in this set 2, 3, 4. Okay? This set is a subset of this set. Yes or no? All the elements present in this set are also there in this set. So it is subset. Second one, A, B, C. A, B, C. This set, check here all the elements are present in this or not. Only B, C present. A is missing and instead of A, D is there in the set. So what I can say, this set is not a subset of this set. Okay. Third one, X such that X is a student of class 11 of your school. Okay, in your school, not only up to 10th, you have 11 and 12 also. X such that, first set we are talking, X such that X is a student of class 11 of your school. See the gap here? X such that, one more set, student of your school. Yes, how can I say in your school 11th class is also a part of your school, right? 11th student is also a subset of your school. Therefore, I can say it is a subset. Fourth one, X such that X is a circle in the plane. Okay, imagine a circle in a plane. Okay, let me draw a circle. Right? X such that, one more set, X such that X is a circle in the same plane with radius 1 unit. See here, with the radius 1 unit specified in this set. But what about this radius? We don't know. We don't have a clarity about this problem. Look here, first one is a circle in a plane and second one is circle in same plane with radius 1 unit. Either it may be inside or outside. Those all we don't know. So what we can say, therefore, this set is not a subset of this set. See the fifth one, x such that x is a triangle in a plane. And one more set, x such that x is a rectangle in a plane. See here, both are different figures, triangle and rectangle. So I cannot say that they are subsets of this sets. So what I can say, not a subset. See the last two here, x such that x is an equilateral triangle in a plane. Equilateral triangle. And x such that x is a triangle in the same plane. Suppose if I take a triangle, any triangle, maybe all sides not equal, two sides equal. Suppose any triangle you imagine, in this triangle, suppose if I take an equilateral triangle where all sides are equal. I say that this equilateral triangle is subset of this triangle. Yes? Yes or no? Yes, equilateral triangle is a subset of any triangle. Next one, x such that x is an even natural number. What we need to remember? Even natural numbers. Start saying 2, 4, 6, 8, so on, right? What is the other set? X such that x is an integer. See here, 2, 4, 6, so on. These are even natural numbers. Even natural numbers are the subsets of integers. Integers contain 0 positive numbers and also negative numbers. All positive numbers will be there. Among them you can see even natural numbers. So these are subsets of integers. Okay, these two you go with subset. Coming to your second main, examine whether the following statements are true or false. Okay, look here. AB set is not a subset of BCA. See there, AB not a subset of BCA set given here. See here, elements in this set AB are present in this set. So I can say this is a subset of this set. So what you can say, therefore what they have given is not a subset is false. This is false because it is a subset of this set. Next one, AE set is subset of x such that x is an oval in English alphabet. What are all the ovals of English alphabet? A, E, I, O, U. In A, E, I, O, U, AE present. So it is a subset. So what you can say this one? This is true. Next one. 1, 2, 3. Subset of 1, 3, 5. See all the elements present in this set. 1, 3 there. What about 2? 2 is not there. So it is not a subset. But they have given subset. So what you can say this one? It is false. Next one, fourth one. You have only A in this set. I can say this as singleton set because having only single element. Right? Now, this set is subset of a set containing ABC. Yes, A is present in this. I am going to accept this by saying true. And this one, A set belongs to ABC set. Do you use belongs to when you are writing set? No. So this is false. When you are writing with set form, you should write here subset. If you want to use belongs to, how you need to write? A belongs to ABC set, you can say. Okay? A belongs to this set. If you use brackets, you should say subset. And last problem, x such that x is an even natural number less than 6. Even natural number less than 6. What are those? 2, 4. Less than 6, 6 won't be there. Subset of 2, 6, subset of x such that x is a natural number which divides 36. Which divides 36 means you may have 2, 4, 6 like this. You can take all the numbers. In that 2 6 present. Therefore, this set is subset of this set. Right? Divides 36. Not only these 3 numbers. You can take other numbers also. Okay, 2, 6. These 2 elements are present in this set. Therefore, I can say this is a subset of this set. Let's see the third main. Let A is equal to 1, 2, 3, 4 set, comma 5. Which of the following statements are incorrect and why? So, in this we have 11 sub-questions. Let us see here first one. 3, comma 4. This set, subset of A. Immediately what do you say? Yes, it is enclosed with brackets. It is a subset, you can say. But in a given set, this is also an element. When this is an element, you should enclose it again with brackets and then say it is a subset. Otherwise, what you need to write? This is as an element if you consider, we need to write belongs to. Okay? This is incorrect. Either it is correct or incorrect. This is incorrect and you can say that this 3 belongs to this 3, comma 4. But 3, comma 4. But 3 does not belongs to A set. This 3 maybe belongs to this, but 3 does not belongs to full A set. Therefore, what you can say? This 3, 4 set is not a subset of A. So, this is only an element you need to consider there. Right? In this set, only 3 belongs to this set, but 3 does not belongs to A. Okay? See the second one. 3, comma 4 belongs to A. Yes. Yes, it is correct. 3, comma 4. This set is as an element if you consider. This belongs to A. And the next one. See here, double bracket, subset of A. Yes, it is correct. Why? This is a element enclosed with the flat brackets again. Then it becomes a subset of a set A. Right? This is correct. Fourth one. 1 belongs to A. 1 belongs to A set. Yes, this is also correct. Right? Coming to fifth one. 1 subset of A. Is 1 a subset? No. When you are saying it as a subset, please put with a flat bracket. So what I can say? It is incorrect. Incorrect. I can say it as this one set will be a subset of A. So this one set is a subset of A, not single number 1. What you can write? 1 belongs to A means it is correct. But this is incorrect. Next. Sixth one. 1, 2, 5 set. 1, 2, 5 set is a subset of A. Yes, correct. Next. Seventh one. 1, 2, 5 belongs to A. 1, 2, 5 set, does it belongs to A? No, either elements you can say. 1 belongs to A, 2 belongs to A, 5 belongs to A. See here, 1, 2, 5. This is a set. It is a subset of A you can write. But we should not write belongs to. So, therefore, it is incorrect. Incorrect. What you can say? This set does not belongs to A. It is a subset of A. Okay, next one. Eighth one. 1, 2, 3 set, subset of A. See here, 1, 2. This set I cannot take out separate. As it is full 3, 4 set I need to take. So what I can say? This is not a subset of A. Okay, this is incorrect. Subset of A is incorrect. Why you know? 3 is not separate. 3 along with 4, that set if you write inside, I can say that it is a subset. Now it is not a subset. It is incorrect. Next one, empty set belongs to A. Empty set belongs to A. No, empty set does not belongs to A. Empty set is a subset of A. Okay? It is incorrect. It is incorrect. What you can say? Empty set does not belongs to A, whereas empty set is a subset of A. The last one, empty set is a set subset of A. Already we know that empty set separately it is a subset of A, but not like this. See here, empty set is only subset of A, or this subset of A. See here, either empty set subset of A like this you can give. So either this is subset of A you can say, or this is subset of A you can say, but not this. Any one only it is a subset of A. Then what you can say here? It is incorrect. Okay. Next, coming to your fourth main, write all the subsets of the given sets. So how do we start writing here? Subsets of a given set having only one element, that is A, are, what are all the subsets you can write? Empty set, like this you can write. Always write the subsets with a comma, this one. How many subsets you can write? Only 2. See the second one, same manner write the statement. Subsets of this set containing 2 elements A, B. So every set, empty set is a subset, comma, A, B. A as a set with B as a set, and every set is a subset of itself. There are 4 subsets. See the third one, 1, 2, 3. Write all the subsets. Empty set, 1 as a set, 2, comma, 3. Next, with 2 numbers, 1, 2, 2, 3, comma, 3, 1. And same set you need to write now, 1, 2, 3. Okay. So now, write the subsets for this set. How many subsets you can write with this? I cannot write any subsets. Empty set subset is empty set only. Okay. So the next one, fifth one. How many elements have P of A? What is P of A? Power set of A. Right? Power set of A, where A set is empty set. So power set of A, see here, all the sets you need to write, right? Only this I can write. So how many elements are there? Though only empty set, there are no element. But in power set, if you write empty set, I can consider this as one element. That is equal to number of elements in power set. N of P of A is equal to 1. So N of P of A, number of elements in power set, is equal to 1, I say. Or you may remember in this manner. That is 2 power. A has how many elements? There are no elements. That means 2 power 0 elements. 2 power 0 is 1. Okay, no elements means 0 elements. N of A is equal to 0. Whereas coming to N of P of A, you can say it as 1 element. Right? Sixth main. Write the given set builder form into number notation. Notation you have seen, right? See the first one, X such that X belongs to R. X belongs to real numbers. -4, 2 numbers -4 and 6. Notation intervals, you need to use brackets. Open bracket, closed bracket. Which one you need to take here? See here, x is greater than -4. But -4 won't be there. Open bracket here. See, x is less than or equal to 6. Square bracket we need to take. Like this we need to write the intervals. See the second one. X such that x belongs to real numbers. X is greater than -12, less than -10. Greater than -12, less than -10. Can you see anywhere here equal to? Not there. So I go with open brackets -12 comma -10. Finished. See the third one. See here equal to sign there. Here there is no equal to. When you see equal to sign, better go with square bracket and that side open bracket. 0 comma 7. Right? And here next one. X such that x belongs to real numbers. X is greater than or equal to 3, less than or equal to 4. That means both the numbers are included. Included means we take with square bracket. Is this clear? Seventh mean, write the following intervals in set builder form. See here, you can see the intervals. 4 sub questions are given. How we are going to write this in set builder form? Flower brackets, x such that x belongs to real numbers, comma. See what are the numbers you have? -3, 0, x you take in middle. What is the interval you can say? It is a open interval. Open interval means just you write -3 less than. Finished. That means x is greater than -3 less than 0. Okay, that's it. Same manner. Next one. See closed interval you can see. X such that x belongs to real numbers, comma. Write the two numbers here 6, 12, x. Okay. Closed. Closed means less than or equal to, less than or equal to. And how do you read this? X is greater than or equal to 6 and less than or equal to 12. Because it is a closed interval. 6 and 12 also included. See the next one. 6 comma 12. Open interval, closed interval here. X such that x belongs to real numbers. Take the numbers here 6, 12, x in middle. See here it is open. Only less than you write here. It is closed. Less than or equal to. Now read this. X is greater than 6. 6 won't be there. Less than or equal to 12. 12 is included. Where if you have this bracket, this is excluded and this is included. Very easy to remember. Suppose you have an open bracket, only less than you write. Closed bracket, less than or equal to you can write. Okay, last one. See here, -23 comma 5. This is closed interval and this is open interval. How do you write? X such that x belongs to real numbers are, and write the numbers -23, 5, x in middle. Closed, less than or equal to. Open, only less than. Now read this one. X is greater than or equal to -23, less than 5. Okay, is this clear? If you have any confusion with this intervals, easy to remember. Suppose if you see an open interval, don't use equal to symbol. Okay, if you have a closed interval, use equal to symbol. That's it. Open, closed. See here only less than I have written and here less than or equal to I have written. Closed, open, less than or equal to less than I have written. Okay, is this clear? Eighth mean, what universal set S would you propose for each of the following? Each of the following, there are 2 questions in this. The set of right triangles. Right triangles universal set means it contains all the sets in it. So universal set, I can say that set of all triangles. In all triangles, right angle is one part of this triangle. Set of all triangles, if I take as a universal set, then this will be subset. Okay. Same manner, if I take set of isosceles triangles, if I write same set here also I can write. What is a universal set for this? What is a universal set for this you propose? Same set of all triangles. Coming to your last main in this exercise, see here, there are three sets given. A is equal to 1, 3, 5, B is equal to 2, 4, 6, C is equal to 0, 2, 4, 6, 8. So see all the three sets A, B, C. Take all the three sets into consideration and which will be the universal set among these four. What do you mean by universal set? It is a set which contains all the elements in other sets. Right? See here 1, 3, 5. First one, let me start checking. 1, 3, 5 present. Okay. B 2, 4, 6. 2, 4, 6 present. C 0, 2, 4, 6, 8. 0, 2, 4, 6. 8 not there. So I cannot consider this set as a universal set. See the second one, empty set. No, there are many elements. This is also wrong. 1, 3, 5. 1, 3, 5 there. And B set 2, 4, 6 there. Coming to C set 0, 2, 4, 6, 8. Extra also you have, right? All the three sets, that is A, B, C, all the elements are present in this set. So I can consider this as a universal set. Extra elements you can have, no problem. This is called as a universal set. I can consider with you. If you want, you can check it out. Fourth one, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 0 is missing in this. So I cannot consider it as a universal set. Suppose if 0 is there in this set and this is not given, then I can consider this as a universal set if 0 there. Okay, now 0 is not there. So this is not a universal set. So which one you are going to propose? This one as a universal set, because all the elements present in the three sets are there in this set. Extra you may have, no problem, but all the elements must be there, right? So with this we are going to complete our exercise 1.3 and we are going to meet in our next session with next exercise. Until that, keep watching. Thank you all.